Hello everyone, welcome to GS Geography with Preexisting. So today's topic is tropical cyclone. This topic is in the news because of two cyclones recently hit in the month of May and the first week of the June in Bay of Bengal and Arabian Sea in Amphan and the Nisara. Now, this word called tropical cyclone is causing a storm when the speed is crossing more than 61 kilometer per hour. So locally known by different names according to the location of its occurrence and hitting the coastal areas. If the cyclones are produced over South China Sea and hitting the China, then it is called as typhoon. When it is caused in the Philippine Sea and hitting the Philippines, called as Baiju. When it is hitting the Japan, called as typhoon. When it is hitting the north of the Australia, called as Willy Willy, and in the northern Indian Ocean, both Bay of Bengal and Arabian Sea or the surrounding land masses is called as cyclone, or the water bodies surrounding the America, all kind of America, north, south, and the Central America, both Atlantic and the Pacific side, called as hurricanes. Now, question arises: how this is the cyclone? Tropical cyclones are defined. So, tropical cyclone is a low pressure center which is characterized by the inward flow of wind with a great speed. When the speed is crossing more than a 61 kilometer per hour, then the depression is being declared as a tropical cyclone or a storm. And so it is representing the location of intense thermodynamic atmospheric instability. As a result, the heat energy moisture is convectively rising upward with a great force, and this is empowering the tropical cyclone. All the tropical cyclones form over warm water bodies and move from sea to the land, and they decay there only. So let's see the process of the tropical cyclone formation. So first, tropical cyclone formation, the word itself say first requirement is tropical characteristic. Tropical characteristics are found between the Tropic of Cancer and Tropic of Capricorn. So we know the sunlight is directly falling near the equator between the Tropic of Cancer and Tropic of Capricorn. So this area get heated up, and this heating will generate the low pressure center, now or also called ITZ or the depressions. Now this formation or conversion of this low pressure into a tropical cyclone, the process called as tropical cyclogenesis. So in this process, there is a warm core developed in a cyclone where the significant convection is being favored by the environmental condition, especially within the tropics. Sunlights are directly hitting. As a result of intense heating, the air get warmed up and the warm air rises upward. As a result of this, on the ground low pressure is being developed as we compare to the locations where the inclined or the indirect sunlight is being falling. Now there are certain preconditions which is required for the cyclone formation. So six preconditions we are observing here. First is a warm sea surface temperature, which is more than 26.5 degrees Celsius. It can be 27, 28 or 30, 35. It's been possible. So because of this warm water body, so the high rate of evaporation take place. Even because of tropical nature, even the air above that is also warmer. Even the air temperature is higher. We know the warmer air able to hold more and more moisture. As a result, that air is start rising upward, and that area where the air is vertically rising upward along with the moisture is called atmospheric instability, and that leading to the convectional rise of moist air upward. Now because of this convectional rise of moist air, so large continuous supply of moisture is there to the lower and the middle level of the troposphere. So that means below the height of 6 kilometers, large quantity of moisture get developed. Okay, and this moisture on reaching into the higher altitude undergo what called condensation, that release the latent heat, and the latent heat is doing or fueling the low pressure center further and further. Now, because of that cloud formation, when the moisture is rising upward, it is forming what called the cloud because of cooling of the moist air in the upper layers of the troposphere. So the series of these thunderstorm clouds start developing. Okay, and this thunderstorm cloud has to emerge somewhere. So requirement is pre-existing low pressure centers, or these are also called disturbance, which has been created by the monsoonal trough or ITZ. So location where monsoonal trough or ITZ is existing, that will attract all the thunderstorm cloud which is formed by the previous process. Now these cloud may be blown away by the wind system or the surface if it is strong. So the surface wind should be calm and gentle. Now, because on the ground this low pressure has been created, and this low pressure is attracting the wind from all the direction. Okay, so now the possibility is it will meet the low pressure center, rise vertically upward, and there will be cloud formation, and that will falls back and the system may decay. So before meeting this low pressure, the incoming wind should rise vertically upward. For that, the Coriolis force should be non-zero because of the spin of the earth. So when the inward coming air in the northern hemisphere circulated in the anti-clockwise direction, while in the southern hemisphere it is rotated in the clockwise. Suppose this is the northern hemisphere, it's rotated in the anti-clockwise direction, while in the southern hemisphere it rotated in the clockwise direction. Okay, we know the wind always move from high pressure center to what called low pressure center. Look at the mechanism here. Okay, in the northern hemisphere, what is happening if there is a low pressure center? Imagine, and the air is moving inward to fill this low pressure center from all the directions. So cooler air try to come and to fill this low pressure center. Because of Coriolis effect, unable to fill this low pressure, but start rotating spirally. Now, in which direction in the northern hemisphere due to Coriolis effect when rotate, it deflects towards the right, and right of this direction is clockwise or anti-clockwise. You can see in this sketch and say it is moving in the anti-clockwise direction, isn't it or not? Similarly, in the southern hemisphere, the wind rotated in the clockwise direction, and such circulatory wind system is called as first called depression. When the energy increase further and the speed of the wind crosses the speed more than 61 km per hour, then the deep depression convert into what called cyclone. How this process happen? Now, if you look at this, it is a warm water body whose sea surface temperature is more than 26.5 degrees Celsius. So, as a result of this, the higher rate of evaporation take place. So, the latent heat is being taken by the vapors, and the moisture is added into the atmosphere. And which areas of the atmosphere? In the lower atmosphere as well as the mid-altitude atmosphere below the 6 kilometer, lot of moisture is get added. So when it's reaching there, air get cooled down and form the clouds. So series of thunderstorm clouds develop, and during the condensation process, lot of heat energy is released. So as a result of that heat energy, so entire system become thermodynamically very active, and this is merging with the pre-existing low pressure center. So with the time, more and more vapor, more and more low pressure is been intensified, and this low pressure center is called the eye. Now what happened? This eye is actually growing, okay, and for that to maintain it, it needs 4 to 5 days or further to similar kind of situation should be existing. So who will maintain the similar situation of warmness and should not be moving? So upper atmospheric high pressure condition that is maintained by the jet stream should be existing. From the top, it is exerting the high pressure. So as a result, on the ground, low pressure remain maintained. That because of this high pressure, the cooler air, okay, it start descending downward, okay, and this subsidence maintain the low pressure on the ground. One kind of system is maintained between the tropopause and the ground condition. When high and the low is maintained, the system is not moving anywhere, and situation staying for 4 to 5 days, then this low pressure will enlarge, and the diameter of the low pressure or the eye will be having 5 to 35 kilometers in diameter. The entire cyclone will attain the diameter of 300 to what called 500 a kilometer. It's a very big, and sometimes it is also observed it may reaches to 1000 kilometer. So it is very big, and it is the rarest of rare it attain. Now what will happen? This air from on the ground is try to rush to fill this low pressure center, but in the high pressure in the upper atmosphere, air try to diverge and try to move outward. So the ground condition is a convergence center, okay, and the upper atmosphere is a divergence center, and the system of circulatory wind system get developed. Now, once the circulatory wind system develop, what happened? So we call that the wind speed has been seen. Like in the circulatory wind system, what is the speed of the wind? Wind is increasing actually when it is crossing 61. We call, okay, storm. So the storm may turn into the super cyclonic storm when the speed is crossing 222 km per hour. Please see the topic called categorization of tropical cyclone by IMD classification, even the hurricane classification by the Americans. Now, once the cyclones develop, they try to move from sea to land. So, what are the factors is describing or deciding the movement of a tropical cyclone from sea to land? In generally, what has been observed, they move from east to west direction. So as a result of this westward movement caused mainly by the trade wind, the east coast experienced more tropical cyclone than the west coast. The rate at which this tropical cyclone move east to west or westward movement is 300 to 500 km per day, and this entire cyclonic movement towards the land is a slow process. Okay, when the direction get reversed, that means start moving poleward or towards the east, then such kind of movement generally of cyclone is called recurving of cyclone, or the deviation of original path of a cyclone from general to the poleward and eastward is called recurving of cyclones. Okay, so what are the factors that decide the normal or the recurving path? So there are around 6 factors, or 2 or 3 is more important, the rest of them is minor factor. Most important factor that decide the path or the track of a tropical cyclone is environmental steering. That means nothing but a prevailing surface wind which is caused by the trade winds or the tropical easterly winds. Okay, we know the trade wind move from east to west, generally they also move from east to west. Even the monsoonal winds or the seasonal wind which occurs in the intertropical convergence zone or monsoonal trough also push the tropical cyclone in its direction. For example, if cyclone is formed here, the northeasterly trade wind shifted from east to west. Even this southwest wind, monsoonal wind shifting from this to this. So direction actually also been decided accordingly. Now, so this factor is called as what called the environmental steering. It's nothing but surface wind. For example, so this is an ITCZ location or monsoonal trough location. So in the month of July, ITZ is in the northern hemisphere called as NITZ. In the month of January, the NITZ in southern hemisphere called SITZ. In this location, the monsoonal climate or monsoonal low pressure system is existing, or also called intertropical convergence zone. Now, if the cyclones are formed here, it is under the influence of the winds which is located here. If the cyclones reaches here, it will come under the influence of what called westerlies, isn't it not? Okay, try to see that's where it is under the effect. Another factor apart from this environmental steering, second important factor that decide the path or the track of a tropical cyclone is a beta drift. Beta drift is nothing but role of the Coriolis effect in a moving or rotating tropical cyclone taken in the superposition. We know as we go from equator towards the pole, what happened, the Coriolis force is also increasing. We know Coriolis force directly proportional to sine theta, where theta is the angle of latitude. In the higher latitude, because of Coriolis or Ferrel's law, there will be more and more deflection of the wind. In the northern hemisphere, as per the Ferrell's law, deflection is towards the right, while in the southern hemisphere, deflection is towards the left. Now, this beta drift is caused or induced by the storm itself because of rotation as well as Coriolis effect. Even though there is no role of environmental steering, beta drift is acting. And because of this, your storm appeared to be actually drifted in two directions, poleward as well as eastward. And this is also called recurving of the path. Okay, so this is very important factor. Let's see here. So generally it is moving from east to west, and because of the Coriolis effect, it turns poleward and towards the right in the northern hemisphere. Okay, so when it's turning right, so this is called poleward shift, and this is called as eastward shift in the north. Similarly, in the southern hemisphere, of the poleward and eastward, and this entire concept called beta drift. This is a major reason for recurving of the cyclones, okay, in the tropical areas. So other factors are minor, such as like when two or more tropical cyclones are interacting, and then the new average point, both the cyclones start rotating or orbiting, then they may change the direction, and this is called Fujiwara effect, observed by the Japanese scientist. Another factor, this is also small, but in the Indian case, it's also more active. Even in the Atlantic Ocean, in the Gulf of the Mexico, also active. The interaction of tropical cyclones, especially in the mid latitude, where the westerlies are there, or jet streams are there, or extra tropical cyclones are there, and all these are moving from where to where? West to east. So as a result of this, whatever the tropical cyclones enters above Tropic of Cancer or Tropic of Capricorn, they came into the contact of the winds which is moving from west to east, such as westerlies or in the ground, or jet stream in the upper atmosphere, or also in the extra tropical cyclone that push it from where to where? West to east. And this eastward shifting is also responsible for called recurving. So in India, this factor is also active. Okay, now the local topography at the coast, okay, where the cyclone hit the land, that location is called landfall, and where the speed of the cyclone is the maximum, after hitting the path may get deviated from the original direction. Okay, even if it is weak, then it may decay completely, and this because of the cutoff of the continuous supply of moisture from the sea, because the major source of energy to drive the tropical cyclones come from the latent heat released during the condensation process, and when it reaches to the land, this supply chain is completely cut off. One smaller factor is also affecting, that is called as the upwelling and downwelling of the seawater because of INSO effect. INSO means El Nino, southern oscillation. We already know because of that, whenever upwelling takes place, it will leading to the colder water at the surface. Colder water will suppress the formation of tropical cyclone, and the warmer water which caused by the downwelling process will intensify this thing. And this system of INSO come from the Pacific and try to move towards India. So the Bay of Bengal side has more effect than the Arabian Sea. Now, when we see the synoptic chart of weather or tropical cyclone movement in general, we can see that they are moving from east to west, also the westward movement, or somewhat to the northwest direction because of tropical easterlies or trade winds. If there is a change in the track to the poleward or eastward, then this system is called as recurving. Recurving can be possible very sharply or rapidly, okay, towards the northeast or easterly, or slowly is also possible. For example, Mora or the Okchi cyclone in the year 2017 is the slow one. Okay, but Okchi has a little intense. Recently, Nisarga cyclone, which hit the Maharashtra coast near Alibag, has more adverse impact. Once again, you look at this question. what is recurving and why the recurving of cyclone take place. Recurving of cyclone or recurved cyclones are those which change the path, and the change path is towards the pole and towards the east from the general direction is of west or north west direction. So what are the reason for this recurving cyclone? First important factor is correlates effect of rotation of the earth, and because of rotation of the earth in northern hemisphere, deflection is towards the right, and the right shift leading to the poleward or the eastward. In the southern hemisphere, deflection is towards the left, as a result poleward and the eastward, which you can see here in the sketch 2. Now second factor if the is the westerlies. In when the cyclone is moving above the ITCZ zone, okay, then the westerlies wind in the subtropical ridges pushes the cyclone or even crosses the Tropic of Cancer or Capricorn. Westerlies wind in the subtropical ridges push the cyclone west to east. So the eastward flow you can see these of cyclone. Even the local factors like topography of the coastal areas, even the jet stream in the upper atmosphere can drive the cyclone west to westward, or called recurving is caused. One more thing are related to the cyclone. What are the consequences in general? Very crude. We will see in the next video in detail of this. First, the implication of normal tropical cyclone or recurving cyclone. So this disturbance or the damage or hazard is decided on the basis of the wind speed or the location of the landfall or the timing of its occurrence. Okay, if the speed is more, location is urban, large industrial urban center, okay, then it is a time of working, then the damages loss will be more. So before the arrival of this cyclone to the land, it intensifies the cloud cover, thunderstorm activity. Even the sea surge phenomena is also increased. Sea become very difficult to navigate. So the sea navigation is completely suspended. Fishing operations are suspended. Loss of the life and property of the coastal community when it hits the coast. So even uprooting of the trees and damaging the weak building structure because of great speed. It may cross the speed up to 220 to 250 km per hour in case of super cyclone, which was experienced in Indian case in 1999 called Odisha super cyclone. Even removing the transporting networks, road, rail, air, sea, all mode of transport get removed. Our telecommunication network get disrupted. Big fishes like shark, whales reaches to the beaches. Pollution of beaches are there. Flooding of coastal areas affecting the standing crops. Even the other important infrastructures like power lines, communication lines get disrupted. Now, this all abnormalities caused by the sea surge or by the strong winds associated or the heavy rainfall associated with the tropical cyclone is increasing in the present scenario, both in terms of frequency as well as in terms of intensity because of global warming and climate change. Because warming of the atmosphere and warming of the sea is more and more, and the more chances are there. In case of recurving, one more difficulty arises if the speed remain the same, that the path is not being forecasted, tracked properly. No much preparedness is there in this case. So and meteorological department fails to predict the track. It's a difficult phenomena and it's the rarest phenomena. Okay, so during that, even the monsoon time, if cyclones occur, it may delay the progression of southwest monsoon also is possible. For example, Nisarga cyclones which hit the this called Alibag, Ratnagiri, Maharashtra, caused in the Arabian Sea on the 2nd of June 2020 with a speed of 110 km per hour, and the strongest cyclone experienced in the Maharashtra after 1891. So a gap of more than 130 years. You can see this track actually. Okay, one more questions you can expect in your mains. Why more cyclones are observed on the east coast of India comparing to the west coast of India? In or short called, why Bay of Bengal experiences more cyclones, and why more cyclones moving from east to west hitting the east coast more? So the reasons are in the forming conditions as well as in the moving condition of tropical cyclone, and more prevailing over the Bay of Bengal compared to the Arabian Sea. Look at the reasons in particular. First, Bay of Bengal is more warmer than the Arabian Sea because it's smaller in size. Okay, the less deeper, have less saline. We know when the water body is less saline, the melting point or the boiling point is actually lower down, so the more higher rate of evaporation take place. Because of higher rate of evaporation, more and more moisture is added into the atmosphere, and this more moisture into the atmosphere is making this heat engine more and more active, and this heat engine get further fuel by the supply of moisture from the Gulf of Thailand as well as from the South China Sea into Bay of Bengal, entering through the Gulf of Thailand or South China Sea. So even this is a location of stronger ITCZ or monsoonal trough. So as a result, pre-existing condition for depression formation is there, which attract the thunderstorm clouds. Even on the east coast of India, in the Bay of Bengal coast, having large number of rivers falls, okay, forming the large deltas by Ganga, Brahmaputra, Godavari, Krishna, Kaveri, Mahanadi, etc. on this east coast, and this is a wet point, and these wet point attract depressions or the cyclones over the landmass. So that's wherever the cyclones are formed in the Bay of Bengal is moving towards these delta, because these deltas are acting as a wet point, and these wet points are less in the west coast of India or Arabian Sea coast. Even the tropical easterlies, as a surface wind that moves from east to west, is pushing the cyclone westward. So as a result, east coast experience it, but only in the case of recurving, which is occurring if occurs in the Arabian Sea, may hit the west coast of India. Even the role of INSO and IOD means Indian Ocean Dipole Mechanism. You already know what is INSO means, El Nino Southern Oscillation. In the present time, it is getting more and more intense and frequent because of global warming and the climate change caused by the carbon emission, and the more warmer water is being observed over Bay of Bengal, which is increasing with the time. As a result of this, what happened? The intensity and the frequency of cyclone observation in Bay of Bengal is there, because IOD as well as INSO is a effect of El Nino event or the Southern Pacific Ocean warm waters country, which move towards the Bay of Bengal first, and it's more chances of occurrence. And which stage of the INSO or IOD the cyclone formation is more frequent and more intense? In case of negative IOD mechanism, or in case of positive INSO effect, or also positive INSO is also called as La Nina case. Okay. Now one more reason why it has been observed less in the Arabian Sea or the west coast of India. Arabian Sea is very close to the subtropical high pressure belts, where the subsidence of air is taking place, or desert formation of Arabia is there, and the descent of air characterized by the dry air, wind shear, surface winds are strong. So whatever the clouds formed here or whatever the moisture is added, it's not staying there, it's carried away from that particular location and causing rainfall into the land masses. Now, as a result, less chances of conversion of depression into cyclone. That situation has to stay. Okay. Next, more depression are formed or typhoons are formed over the South China Sea across the isthmus, which is very close to the equator, or the isthmus of Kara or the Thailand, Gulf of Malacca into Bay of Bengal. Because of this, fueling the moisture content into Bay of Bengal, which activating the heat engine of tropical cyclone, which we have already See, so what we can conclude, guys? So we can say that warmer Bay of Bengal is actually receiving 80% of the top total cyclones. Okay, and these cyclones are not only in number but also intense in terms of speed. Generally, the maximum speed it's observed on the Bay of Bengal side is more like 220, 230, even 300 kilometer per hour is possible. So this will be a disastrous. Okay, but in case of the Arabian Sea coast, the speed is around 150 kilometer. I think this we have done. So guys, there are other questions that are also possible in tropical cyclones and comparison with the extratropical cyclones, such as one question might be on how to categorize the cyclonic storms by the IMD, Indian Meteorological Department, and how does categorization differ from the Americans hurricane process. Second, why and how the tropical cyclones are named, and discuss the recent procedure which is adopted in the northern Indian Ocean regarding the naming of tropical cyclones. What level of preparedness has been attained by the India against the mitigations steps for the tropical cyclones. Next, how tropical cyclones differ with respect to extratropical cyclones, and find out its relationship with India. Guys, this is for this tropical cyclone, and for the further question we refer to the videos and write in the comment section if you want any specific question to be